try to do a fast video right here about for Go developers who are trying to create automatic CI/CD builds and releases and stuff that involve private repos, and that includes inner source repos on GitHub Enterprise Cloud for your enterprise, which is the very specific requirement that I've had to research and overcome. And so before I get into showing you how all the things work and stuff, let's talk about what the problem is and what the solution is. So the problem that we face is I have a thing that I want to build and I want to release a binary, a Go binary, and it depends on other things that are private, the repos that cannot be seen. And anyone who's done any Go development already knows some of the things you have to do to make that happen, such as the Go private environment variable, which we'll talk about, but there's more to it than that. When you add on CI/CD automation, then the container runners, the containers that do the building and the releasing, have to have access to these private repos. And how do you do that? And this gets pretty complicated pretty quickly because there are so many ways to do it. Um, for me, it helps to think of it in terms of what if I were setting up a virtual machine and I wanted to run my build and whatever code necessary to push the release automatically? How would I do that? And we use Go Releaser, and we'll get to that too. But thinking of it in terms of like how if I were hit, if it was a person doing it, as opposed to an automated runner container doing it, how would the person do it, right? And I think that is going to inform most of the decisions that have to be made. So before we dig in really deeply into this, we do need to talk about how do you even access private repos. And I don't want to go deep into this topic, but we have to at least mention it. So, number one, how do you even access a private repo, right? If you're using GitHub, so again, you're sitting here, you need to access your own private repos on GitHub. How do you access them at all, right? Um, you can set it up through GH. Let's go through it. You could either do the GH command line tool and then paste your token, and then it will get updated in all the right places, or you could do an SSH key and paste that, or you could set up maybe it's you want to access a repo that you don't even own. So you would actually create a deployment key or deployment token. There are many ways to do this. One of them would be and there are so many different layers of possibility when it comes to accessing GitHub that it can be overwhelming. Perhaps one of the biggest decisions about how to access GitHub is whether to use the API via HTTP or to use SSH. And we're going to get into that quite deeply. Those of you who've gone through the boost with me know that my recommended way to set up access to GitHub from the command line and for most all things is to use SSH keys, and to add keys on that will expire over time, and then refresh them. So, and if it gets compromised, you delete it, and then you have a key for your laptop. You have a key for your work environment, and each of those keys it doesn't take much to manage an SSH key pair per method of accessing your account. And the really great thing about that is that you can granularly manage your access. So if something goes wrong with this one and someone stole your laptop, you just delete that, you know, that key, and that's no longer a thing, right? That is they're no longer able to access this. Well, what does this have to do with building Go code? Um, Again, this is the best way to think about how to manage access to, as if it was a person sitting there doing the building. One other thing on this topic. So, when we're talking about SSH keys, we're also talking about, well, is this going to be read or write only? So here's another problem, right? If we had a person and we wanted to give them read access to our private Go repos so that they could build the thing, but we didn't want to give them write access, what would we do? Right? They would set up their own account and they would have, full privileges with GitHub as a user with an account. And then we would say, okay, you have collaborator access on our private repo over here, whether it's, an actual private repo or it's an inner source repo, which is effectively private um, on Enterprise Cloud. And that user would then, if they were building it for us, they would have read-only access to be able to build from our private repo, and they would have to request it, and then they would have to add go private in order to tell it not to go check the checksums and everything. We're going to go through that, and but that's how we would set up an untrusted user or a less trusted user to build our software for us and then do the release for us. So anthropomorphizing this automation is kind of helpful. That imagine a person being given that access and say, okay, we're only going to give you enough access to read it so you can build. And that means you set up a GitHub account, and now you have an SSH key so that you can connect to your account, and then your account is now set up as a collaborator on our account, or at least is given read-only access in whatever way. There's like several ways to this private repo of ours, right? Generally by adding them as a collaborator with read-only access. And that model that we just talked about is going to inform the architectural decisions about how to set up the automation. Most importantly, whether to use a deployment key, an SSH key, or something else, right? The idea of having this separate user over here is the only way, without using deployment keys, that we can. Deployment keys are read-only, right? That we can have deployment keys can be swapped in and out for any place you would have an HTTPS token. So, and for the most part, as I understand it, I might be getting some of this wrong, so please correct me in the comments if I get it wrong. But they're largely dependent on HTTPS, as far as I know, and you don't necessarily want to do that because we want to use SSH. But to use SSH, it's read write. You can't set up an SSH access to set up SSH access to an account. It has to be an account, right? So either you set up another person with an account or a pseudo account, and then that account has those permissions, and then we add one or more keys to that account to build different things, and then we put the private key, we put that into our build processes as we go. I realize that I probably lost a lot of people in this last little discussion, but it's kind of on purpose, because if all of that was totally Greek to you, this video is not for you. Okay, this video is mostly for people that are doing enterprise Go DevOps deployment kind of things and CI/CD, and the rest of this is gonna be justifying and documenting the conclusions that we've made to make this all work with the least amount of hassle. And by hassle, I almost always mean deployment keys. So this is what we're going to do. We're going to have a sample private repo and a sample private package, and we are going to create an automated build to check out to make sure that the build works and that all the things are good. That triggers off of any push of any kind, PR or otherwise. And then we're going to make another workflow action for the release that actually automatically publishes a binary release for 4 different operating systems just by tagging the repo. Okay, so that's what we're going to do from now on, and we're going to go through the design decisions related to that based on the example that I just talked about. So here are the repos. We have sample private package -go. These are private by design. You will not be able to see these on GitHub. I have toyed with the idea of making them public so you could study them, but I just as soon leave it here and have you guys watch the video and go through it. However, once you go through it, I do recommend you get your own, um, because I mean, strictly speaking, you can use this to build public repos too if you wanted to, and then just have one way to do both of them. But we'll let that decision be up to you. The other repo that we have is wait, that's the Go one. That's the we need the package. Okay, so we have the package itself, and then we have the program that uses the package. Okay, and you can see it's already got a release out here, everything. All right, so let's break down what's here. First of all, we have a git ignore just for Go work. Normally, and a lot of people get around these problems by building stuff locally. So this video is about automation. If you're just trying to do a build, then you probably just have to add Go private and be done with it to your environment, and it'll work, right? Because you have access to all the things when you're building on your local machine. So this is particularly about the automation part of it. So the package itself doesn't really have anything in it. It has a go.mod file, which indicates it's a module. What its version is, it's got a lib.go, which is my convention for things that are, I use lib.go usually to be the main one. There's just one function in there that's exported. That's what the public is about. And the actual package is samples. So the import line for this would actually be, you'll see it'll be prefixed with sample. So here we go. Example public hello function, blah, blah, blah. So this is the actual function, testing it out. This actually does not work. I need to fix that. I need to fix that right now. Yeah, that will not work. You know why? Anybody know why? Because I already changed it. Yeah. I realized that I didn't, that's the thing I didn't update. So let's do it. Go test, watch, it won't work. Oh wait, how did it come it worked? Is it gotta go work? Oh, that's why. It's gotta go work. Yeah, go test. Maybe, I don't know, maybe I did it wrong. Let's go see. Lib test. Example public hello function. Oh. Oh, yeah. This is not, that's not even testing anything. Sample public hello func. Or how's that? That's much better. Let's write that. Now it's my Go is taking forever because it's importing it. There it goes. So it said it's sample here, and let me go test. I don't know. It's still not right. Oh, it is. It's printing hello there, and it's right. Okay. Git add -a dot git commit. I know I'm committing to main, which is really bad, but this is just for testing. Update lib test to call function. Git push. And there are, so let's look at what's going on here. So git practice private Go. There is actually, I think there's an action on here to do the build. Is there not? Nope. So this one doesn't have any actions on it. You might want to add actions to your package. I didn't do that because we're focused on the release in this particular task. So there are no workflows over here yet. So on that one, but let's go look at the program that uses it. Here you can see the checkbox. That's how you know that there are actions that are being run on here, and stuff. So what does this look like? I'm actually going to show you by looking at the actual code here. So here's the main.go. We are importing from the package, and we're able to call sample down here, sample.public hello function. Sometimes you'll see stuff like this, but this one is not requiring that. So just to make sure it builds, you could go build and it'll build. And that's, because we can go get it and everything. And why can't we go get it? Because it's in env. Actually, let's do go env grep. I mean, private there. So in order to build this, I've already got it so that, I said, I can build from the local box because I have access to all of my repos, and I have told it I don't care about it. It's a private repo. I'm pretty sure that I also have direct set for Go proxy, so it doesn't even go to the proxy or anything. It just goes straight to GitHub, and it does not mind, so it doesn't check the checksums on the file to see, and it goes straight to it. That's a sort of a separate video, but all right. So let's keep going here. Let's look at. I mean, we already know what it does. That's already been done. Let's do it again. Go build. And sample. You'll see. Hello there. Something first here. And that. So go mod is you see it's got a dependency on this sample private package. By the way, if you don't know, what if it had been this? Yeah, that would not have worked. Or if this stuff had been internal. So we'll talk about that another day. That's it. So we just want it to do what I just did, but we want to do it automatically. So we're going to use something called Go Releaser. And there's actually a Z about this. Go Releaser is pretty much the standard right now to use to do the building. So you can go ahead and do the installer. There's an installer for Go Releaser in my dot files. But let's see here. What errors did we get? Error build sample not contains a main function. That's interesting. Oh. Where am I? Main function. Am I in the wrong thing? Yeah, I'm in the package directory. Derp. All right, so let's do it here. So you can run snapshot main go releaser -- snapshot -- clean, and that'll create. I'm showing you this because I want you to see what it does, and we should probably do a video just on go releaser. So the go releaser file is here. It says don't use cgo. Set up go private like we talked. Go mod tidy to clean everything up. Make stuff for Linux, Windows, and Darwin. And then here's the standard stuff from the document. That's from the Go Releaser site. That says this is tells it what kind of files to make, and how to name them, and not to enter all of these things, and some stuff for Vim, so that it's common no matter what. And then when you do that, you get this. Let's see. Do I have ftree? I don't think I do. Let's do find. So you get all of these files. Probably easier to just go in there. You get these files here. You get all these tarball snapshots and stuff. And so it goes without saying that you should put that on your git ignore, because you're probably going to want to do that on occasion. So you don't want them in there. There's lots of stuff you can put in your git ignore there. But I wanted to show you what Go Releaser is doing when it does it right. That's what it's doing, right? And as I said, you can do Go Releaser and create a dist, and then you can create a release by yourself. And I actually, for a second, I thought I was going to have to do that. Because I thought we hit a hurdle with Go Releaser not understanding SSH, and we actually worked around that. And I can't wait to show you that. Through the help of many people on the internet, who had written about their problems and how to get around it, I was able to figure it out. So let me show you how to do that. So again, we just want to do that. We just want to do that build. And then in addition to that, we want to actually take those artifacts and stick them into a release like this. Now, this is a sample release. It's just got all the artifacts, and I haven't updated anything in the changelog or the section of the release, which you can do after the fact. When you do a lot of commits between tags, those will show up here automatically, and you can then go in and clean them all up and make a nice, pretty release in GitHub. But I tend to do that after the fact. The main thing is we wanted to get these downloadable things, these artifacts, right? And so how do we do that? So let's do a couple things. First of all, let's make I'm going to show you what it does, and I'm going to show you the workflows that tell you how to do it. Okay, so let's put something first here, and we're going to make a change. Git commit main. Again, normally committing to main is a horrible thing to do. Shorten greeting. Git push. What I want to show you is this. So the first action if you don't know about GitHub Actions, the first action is, and they're up here. Click on Actions. The first action is just build, right? And we're going to watch what happens here, and then I'm going to show you what the action file looks like. I am not an expert on GitHub Actions by any stretch, and I've been learning it as I go, just in time, and I will eventually come back and do a deep dive. But we needed this right away because we needed to make sure that our migrations and our refactoring of our API libraries is going to work on, GitHub Enterprise Cloud using private repos, essentially, innersource repos. So here we go. It goes ahead and does the build, and now it's just checking it out. So here we have a successful action. Now, why would we run that action? Really, the only reason to run this action is to ensure that any changes we made are green, and that's what the green dot gives you, and that says it worked, right? So a PR, if you're committing to a PR and you're making, anytime you push a commit to a PR branch, it will run those things, and other people can kind of follow along during your development, which is a separate topic altogether, but really cool. But what we really want is that release, right? So let's do that. So let's go ahead and tag it. I have a little helper command called tag, which just checks to see if I've got a tag, and then it forces push or grabs the latest one. So I'm just going to do tag, and just to see what my tag is. So I'm at 4. So let's go ahead and do tag, as long as it begins with V, which we'll get into. Let's tag it 5. And now when we click on actions, we're going to see a couple of actions kick off the regular build one, but the one we want to watch is release. We'll see that the steps are largely the same up to a certain point, and then it does the extra cool stuff of like preparing the release and sending it up, and having the artifacts match the tag. So it's doing all the stuff to build out our Go environment on the runner, and here you see it's starting to build this stuff. You see here it says using token from GitHub token. That's going to come in later. That's very, very important. The GitHub token grants the Go Releaser program access to this repo's artifacts in order to publish. And that is, if it doesn't have that, it does not know. You'll get a permissions error. It can't push it out. And I did hit a quirk that took me several hours to fix, which we'll get into. Regarding the use of normally GitHub token is fine, but when you start to use SSH the way we have, it pushes the boundaries of the GitHub token, and there's a little quirk there that you have to use to get around by just tweaking the permissions of the action in order to let it still do what it did before, which is publish those artifacts, without having to go down the horrible rabbit hole of creating a personal access token just for the same thing. So there we go. It worked. Now, what do we get out of it? Let's go ahead and check our release. We're going to click on our stuff over here, and we see we have a release 0.5, and there are all the artifacts. You can download those. The checksums are there. I mean, everything, man. This is so cool. It's so funny because Go Releaser is amazing, and I'm going to do a call out for this. So I did this earlier, but I'm going to do it again. If you want an example of a project that has probably the best Go programming skills I've ever seen, ever, is the Go Releaser. The Go Releaser project has my jaw dropping with all of the intelligent design decisions. It's like standing in front of a work of art. And there are really key decisions, not just about naming conventions and stuff, but the organization of the code, and how it was written, how it was laid out, the use of internal judiciously, use of nicks in the runners. I mean, it's just, if you want a good example of a project in Go that you can just study the crap out of and get to know Go intimately and really, learn some of the best practices, some of the best Go developers I've ever met. And I don't know the name of the person. I probably should have it memorized. I probably should sponsor the project. It's so amazing. So just know that and have a look at it. Anyway, so here, and by the way, it's not too hard to clone it. You can go watch my video about how to set up your own clone function. Yeah. Do you want to do that? Go watch my video about how to set up your own clone function, and you can go clone Go Releaser, as easy as this. You can go clone it, and then you can go look at it. You can look through the code. Yeah, it's pretty cool. They also use extensive use. There's also extensive use of actions and workflows in there. So if you're new to those, which I am, you can go in there and play around with those. All right, so it's now time to see how does that work. So the first one we'll look at is the build one. Just to avoid problems, let's go ahead and remove dist out of here. We don't need you anymore. Whoopsie. And so inside of GitHub, oops. Come on, baby. Come on, baby. Here we go. GitHub. I know you're there. Am I the wrong one? Oh my God, Rob. You're so dumb. All right. Here we go. So v.github workflows build. So the build is pretty easy. We're not going to go into GitHub Actions. There's a lot much better documentation. I'm still a total noob. So you have this stuff that says on push. So any push event happens on GitHub, this runs. These environment variables propagate down to everything else. This tells you what container to use, container image to use for your container runner. And then the environment variables to set. Go private is obvious if you don't go. SSH auth sock is a new thing that I normally don't use. And I've started using it more and more since I've learned about this. I've always been a fan of SSH agent for obvious reasons, but I didn't realize that the auth sock could help in these ways. It's basically the same way that Docker had a socket and it allowed everything to kind of just use the socket. Some people hate that, some people like it, but it's kind of nice to help different things that are running use the same thing. These steps are all essentially programs or procedures that run on the container. And they're additive, so if they make any modifications, some of them get cleaned up, but most of the time if they change the file system or something, those changes remain as far as I know. So setup go actions configure for private inner repo access. So this is key. This says we want to use SSH because we're going to set up SSH access. Like I said, if I had a person sitting over there to do the build, right, they would need to set up their SSH access to GitHub, right? And since we're using SSH, we want to force the runner to use SSH and not HTTPS for authentication to GitHub and for Git. So we force this. Be very careful here. Make sure you put a slash at the end. I neglected to put a slash and lost about an hour on that. So add SSH go module private key. These are the individual steps that are going to make this runner able to see other stuff that has been configured that has had the public key added to it, right? So public key, private key pairs, go read about it if you don't know yet. So this says, first of all, add github.com to the known host. So it's not saying, I don't know about you. Next, add the agent auth sock so we have something to talk over. And then add the secret private key. So this was generated using SSH keygen. If you don't know how to generate a public private key pair, look that up. It was generated without a passphrase because it is more or less a deployment key. It's not, but and then that was pasted into. If you go up in here, you go into the settings, and don't worry, these things are obfuscated and can never be seen again. Under secrets and variables, actions, you can see the repository secrets. And you can see that if I click on edit, it won't show you the value because it's secret. In fact, once you store the value, that's it. You can only change it. So be sure that you store it in Vault or something like that if you want that key pair available, particularly if you're doing this because you want to be able to reuse the same key pair for all of your projects that are doing builds against any of the projects that would be allowed to see that, right? And so then you put that you go ahead and update that and put that there. The deployment key works for one repo for one time, but then you're constantly managing repo keys, so it's actually easier to manage the one key pair that you're maybe sharing across multiple projects. You can actually add an organizational private key, and then you would not have to add it to every project that uses it, but you have to have an organization that's cool with you doing that. Um, and that depends on the security model of your company. So once you have that private key in, then this machine, this runner, it's a Ubuntu runner, is exactly the same as if you put in all the stuff there to be able to access that. Now, the private key, for the sake of this demonstration that I put in, was an additional private key that I added to my account. And I'm going to show you where. I'm not going to show you mine. But if you click on your profile or the settings down here, and you go to security, past SSH and GPG keys, you can click on that and you can actually add a key there. If you have if you have command line GH access, the GH command, you can actually add this key from the command line using GH space SSH dash key. I think that's the one that I used. I can't remember. It was a long time ago, but you can add it. It's still obviously GH still has had to have been authenticated, so this doesn't get around the need to see the web and go authenticate as a user at some point. But if you're adding it and you've already recently authenticated a GH on the command line, then you can just do that without having to go do all the clicking and stuff. So that gives us kind of an overview of what's going on with that. And then, of course, then it just does the build. It just runs go build. By this time, when go build runs, it knows about go private, so it doesn't check the checksum validation on the repo itself. It can actually go out and pull it in because this go is using SSH, to go make its connection, and because we told Git, because Go uses Git, we told the Git on this machine, this runner container machine, to use SSH. It knows to go use SSH for that, and this SSH configuration allows it to see that. So bottom line, this works, right? And believe me, it took a long time to get to the point where every single thing was there. Let's now let's go through the release.yaml file. This is probably the one most more you're interested in. This fires off whenever anybody pushes anything or anybody tags a release. And you might want to tweak this so that it only fires off when a tag is pushed and not also a build. It doesn't also do a build. Yeah, I don't know if you saw it. It fired off 2 actions. You could probably tweak this a little bit better so that it only goes off when there is a tag that begins with V. There is another thing you can do down into the steps that also triggers that. I just like having a V up there. I mean, that's alpha, beta, whatever, it'll do it. You can go back into the releases, by the way, if you're doing a beta release. You can do dash beta. You can go in and you can click on pre-release, and then latest will be something else. It's actually kind of nice to do that. I should probably show you that, but that's not a factor of this video. So permissions, right? Okay, so this is something that took me several hours to find, and this one thing gets around a quirk by using. There's going to be at least one person who sees this video who's going to jump for joy when they figure this out, because it is not documented anywhere, and it took me. I mean, I finally found, I think, one issue where they talked about it. So the use of GitHub tokens, secrets.github token, and any of the secrets.github _ are automatic. You can go look them up under the list of official Go actions. GitHub token is a temporary token that is generated for use by the runner to access GitHub, right? And only to access that specific repo for which, in which the GitHub action lives. So this has absolutely nothing to do with being able to talk to that remote package, private package that we want to be able to build with, right? That's all the SSH stuff up here. That's why we have both things there. The only reason this is here is so that Go Releaser has the ability to push up those artifacts. That is the only reason it's there. And the reason for that is because Go Releaser is hard-coded to do that. Go Releaser does see SSH URLs and some other things, but after hours of experimentation, um, it just became the easiest to do. I mean, this works whether or not you're using private repos or not, right? You put this here, it says GitHub token, and Go Releaser's like super happy. It uses that token just to push up the artifacts, and then when the runner gets destroyed, that token is immediately destroyed. It doesn't exist anywhere else, and it's all automated. So there's no deployment keys to mess with. There's no SSH keys to push up or anything like that. There's no pseudo accounts to create. There's just so for a Go Releaser, generally speaking, you're going to want that. But somebody's probably going to look at that and go, well, why am I not just using the SSH key already up here? Because this SSH key is not granting access in this particular case to that same repo. It can be used for that, but it's mostly used to grant access to another repo that we are going to give it access to. Okay. And how do we give it that access? Well, the way that we've given it that access is we add, as I said, in the user account of the repo owner or a user who has collaborator access on the repo, we have added a public key, SSH key, to the security settings of that user, not repo. Not repo, user. I know that's a lot. Pause the video and process that. It's really important you get that. So this then is what allows us, so when the runner is generated, any commands that are going to access these private repos need to know the private key. So we put them in the secrets for that repo that's doing the building. It has to have the private key in it. Or if we have an organization, we can put secrets for the organization, and we can put that private key, that specific private key for those builds into that if we wanted to. And then that would be just one thing to manage as opposed to having to change the deployment key on every single thing. And then when you run this, Go Releaser checks it out, and then it goes and does a release, and then it pushes up the data. So, again, I just want to say this tech that we're talking about is extremely complicated and extremely dense for someone who's just starting out. If you're on this channel or you're watching this video because you have done the beginner boost and you're trying to learn stuff necessary to become a DevOps person, this is not low-hanging fruit. This is, and it's also security related. So, this is where I'm going to put in my mandatory disclaimer. If you don't know what I'm talking about, make sure you understand everything before you go deploying this in your enterprise or you use it in your in your system, because you might end up violating your own security policies of your company. You might, so just be cautious. But this video is directly made for specifically enterprise DevOps people and senior enterprise developers in Go who are struggling with facilitating builds of their stuff that has multiple external private repo dependencies, because inner source repos, GitHub Enterprise Cloud, are private by definition. And as far as we know, and my God, would I love to be wrong on this, as far as we know, there is no way to give internal access to all the users and members of a particular organization to all of the other repos in that organization by default. And that's what many of you may have come to be accustomed to if you've used GitHub Enterprise Server. GitHub Enterprise Server is like operating your own GitHub internally, and then all of your repos are public, right? And you can build from them. And there's also an internal, but so this issue of having to set up SSH to do these connections that we're talking about here is completely unnecessary if you're using GitHub Enterprise Server. That's an on-prem deployment. But if you're doing GitHub Enterprise Cloud, then all of that stuff that's there to save you and protect you and allow it to be on the cloud effectively makes every single thing you make private. And therefore, you have to go through this hassle. Again, it took me more than a week to figure out all the intricacies of this. And my organization, I don't mind saying, has no idea how to do any of this. And they are a huge multinational corporation, and they have They have nobody in the company has figured this out. So we are, documenting this internally and helping people to figure out how to do this as we move most of our code to Go, and as we do a lot of migration to GitHub Enterprise Cloud, using the inner source kind of idea. So I hope this has been beneficial to you. If you have questions, please hit me up on the Discord. Um, and if you want some more direction on the specifics of how to code and Go, that's something that we do in the beginner boost. If you don't have any idea how to do a GitHub action and have never done one, I am not the guy to go to for that. If you want to struggle along with me, you can watch some of my co-learning. I am going to be now doing a very deep dive for my own personal needs to get really good with GitHub Actions. I need to really know everything about them. Very ironically, a year ago, actually 2 years ago, when I got to this particular job, I asked about GitHub Actions, like, why are we not using GitHub Actions? And they're like, well, because it costs too much money and we have to run the infrastructure. We're paying for it, but we're not using it because we didn't put up all the support infrastructure. And it's a little surprising that, about a year and a half after that, the entire corporate direction is to use GitHub Enterprise Cloud. And, I find this to be completely interesting because, and one of the main drivers for that was actions. And so I put off deep diving into actions because I didn't think I was going to be able to use them on the job. And now they are sort of essential learning for anyone on our team who wants to do any deployment whatsoever, from documentation. And I've done several videos about make docs and how we use that internally, and to go development and API creation. So I'll just conclude with that. If you for a second, I mean, you can have disagreements with Microsoft or and their ownership and management of GitHub or whatever, it doesn't matter. If GitHub Actions have become like, mandatory learning for any tech job at all. I mean, they really have. If your organization is on GitHub, and there are a few that are still using GitLab, but if your organization is using GitHub either internally or eventually even going to go to the cloud, you got to learn them. You got to learn them. So they've just gone to a nice to know to a mandatory learning in my sort of plan for learning. And I would suggest that other people give that strong consideration as well. That's all for me. Bye.